Today we are here to discuss about mine planning as well as mine scheduling. I suppose we'd better to start with your general question. You first.
Should I go ahead?
Yeah, come on.
Yeah. So the question rises here is, I was just curious about how we start initiate a project. Like, let's say we are going to initiate an open pit mine, starting with doing the planning through like any software. Like in this case, we're talking about Whittle, which would be starting from getting the geotechnical reports and like all the necessary reports and stuff that we have through doing this our case study and evaluating different scenarios and this sort of stuff. My question was if you would be able to give me a thorough explanation of the sequencing of these initiation, like I mean, starting with Whittle, doing and evaluating different scenarios, and then going through a design software such as Deswik, Swpack, or whatever it is, and doing the design stuff of the pit itself, and like road ramp design, the pit design, and then the pushbacks, and then scheduling. In other words, if I want to like not make it too complicated, anything that leads us to do the scheduling, no matter what, if it's a long-term schedule or short-term schedule, anything before that, what's the first steps towards scheduling?
Well, before we start talking about mine planning or scheduling, we should take into consideration that scheduling and planning are not really the two words that can be used interchangeably. It's very important fundamentally to know what is scheduling and what's planning. Uh, Briefly, scheduling will deal with the details such as the available inventory, the capacities and rates, resource allocation to chase some tasks, some blocks in terms of mine planning and open pit to meet some targets, some predefined targets, and do evaluation calculations in this regard, as well as defining the sequence to do each of the activities and meeting that target. But planning is to some extent a more general word that apart from these stuffs, it also considers the decision making procedure and the pit design as well. And I mean that pit designing is part of mine planning, as well as communicating the mine plan. But to elaborate this, we'd better first take some samples, and this will makes this difference between planning and scheduling more clear. Well, the planning, I believe that planning in mining is very different to other industries, that it starts from optimization, especially for open pit mining, open cut mining, that pit optimization is something very different than I'm saying that mine planning starts with optimization, and based on optimization, that itself includes several scenarios to be studied. It's really a study. Mine optimization and planning, especially for strategic planning, is really a study. Based on the results from pit optimization, we choose some pushback strategies that are some of several pit shells. All of them are MPV pit shells, net profit value pit shells. And then based on this pushback selection, or during the mine planning, we choose these pushbacks, these pit shells, and it will define, and it will be the basis for mine planning and scheduling. So next it comes tactical planning. Based on the results from strategical planning, we should do tactical planning. That I have opened a project that is based on a strategic planning output from Whittle. I have imported the pit shells to Mineshed, and I have also used Serpack to do some modifications to the DTM's output from Whittle. Then I import the revised pushbacks to Mineshed so I can do tactical planning. Tactical planning, like strategic planning, is for decision making, and by someone's word, none of the strategic planning and tactical planning are going to be implemented, or I better say are going to be operated. The only planning or scheduling level in mining that is going to be operated is operational planning, or executive planning in some words. That is another level of planning and scheduling in mining. But what's the use of tactical planning? It's to ensure the results of strategic planning, that is the previous step, are viable in more details, especially in complicated geometric advances of working phases, accesses, ramping systems, and more detailed resource allocations. There are many differences between the types and the level of details that we use in strategic planning and tactical planning. Also, the limitations that we put on to the software or planning process is different between these two levels. And finally, the results of strategic planning and tactical planning are to some extent different. But generally, by my idea, tactical planning is to validate the results from strategic planning, and it will help us assess the risks more clearly and in a more detailed stage. And wherever and whenever we see conflicts and maybe some parts of the results from strategic planning which are not applicable and are not viable by doing tactical planning, we should get back the results to the strategic planning and revise it, and it will create a cycle between these two levels. And by any changes to the input parameters, for example, geotechnical model, resource block model, and machinery resources, each of these two levels or both of these two levels must be revised during the life of the mine. I hope that I have discussed enough to get the right answer to a question.
Yep, that'll be fine. Thanks.
Well, what's your next question, or shall I show you some examples about tactical planning, both in long term and mid term? Then, if we have another session, we can deal in more details with operational scheduling or planning.
Yeah, I think that'll work well. Like we can proceed with tactical and strategic planning samples. Just a quick review, and then we'll go from there.
Well, for strategic planning, wait a moment so I can open some of my old projects to show you the results. Here, I'm showing you one of my recent projects that was an iron ore mine, open pit mine. And first of all, as a simplified project in pit optimization and strategic mine planning, we are here importing the resource block model and do any modification to this block model we may need, and then defining the geotechnical aspects that here are in terms of pit wall slopes, and by different runs for optimization, I'm getting several sets of pit shells, and by studying them through some diagrams and validating them graphically, I choose one of these pit shell sets, and here I have some comments about it. And this is the set of pit shells that manually or automatically we must choose some of these pit shells as our nominated pushbacks for the next step, that is mine planning. Here you see these pit shells. You see some pit shells. They are growing pit shells, and some of them only have minor movements on some of the walls, but the others have large jumps that we call them in strategic planning as revenue gaps. Like here, you see here we see different growth in pit volume, both in ore and waste volume. And by the algorithm that every strategic mine planning software packages which may have, among these sets of pit shells, some pit shells will be nominated and then will be planned based on these nominated pit shells as pushbacks, and it is called pushback strategy. In this case, I needed to add some manual pit shells because of two revenue gaps during the life of mine, which I can show you here. I imported 11 pit shells. That three of them, number 1, 2, and number 8, are manual pit shells designed in Serpac to cover the revenue gap. You see here their locations related to the topography. And again, among these 11 nominated pit shells, I started to do mine planning. By mine planning, you need some other data and settings, such as the processing plant capacity, throughput, and mining capacity. Like this scenario, that is my nominated scenario here. Mining capacity has been varied over the period. If we assume that periods are years here, I have changed the mining capacity from 12.5 million tons to 15 million tons from the beginning of year 5. Also, the throughput capacity of the processing plant is going to be changed. And also, maybe you want to consider the replacement capital cost when you increase or do any changes in your machinery resources, or I better say production rates, during the life of mine. So it means that you should do a new capital cost that is called here as replacement capital cost. In this case, in the beginning of year 5, you need to increase your haulage or your loading, as well as other fleets of machinery to double the mining rate. So some millions of dollars should be set here, but it's optional because it's only reflected in the DCF, I mean discounted cash flow table, not in the results that I aimed from this project.
Okay.
Well, by running this scenario and through using some algorithm that Whittle has for scheduling, like Milova MPV, Milova balance, and in 3 adjustments, manual, auto, and semi-automatic, I tell them the software how many pushbacks the software must choose between the surfaces or nominated pit shells I'm loading. That the results of running this node is that pit shells number 1, 4, 6, 9, and 11 are chosen by semi-automatic settings of Milova balance. We are not going to discuss about these settings. I just wanted to say what are the inputs, or the main inputs we must consider when we are pit optimizing and strategic mine planning. Let's take a brief look at the results. One of the results can be illustrated in diagrams like this, or more complex, more detailed diagrams showing tonnage, grade, fluctuations over the each period. The horizontal line is 10 years period, and here I only showed the ore that is input to the processing plant against the waste rock mining tonnage, and the stacking column shows the total mining rate or capacity per each period, and you see that after several runs in previous steps, to compensate the shortage in access to the ore from the pit, we are forced to increase our mining capacity from year 5 and again in year 6, but in later years from 8, 9 and 10, the amount of waste is reduced, and we can dismiss our most part of our fleets gradually during these 3 ending years. More detailed diagrams can be generated here, as well as the summary which shows the NPV for this scenario and this project in any currencies, how much ore is mined, how much waste is rejected or dumped, and what is the average grade input to the factory, as well as pit utilization percentage, and the other financial KPIs like IRR or payback in terms of years or other periods we have assumed, and payback ratio. You see that the life of mine is about 10 years. These are some of the main results from strategic planning, and we can see here that the algorithm has choose how to mine between these nominated pit shells during each period. Every click is 1 year advancing. You see here, for example, at the end of year 3, I have 2 working phases, or I better say 3 working phases. One of them is at the bottom, that is probably where the ore is located. The other is here, approximately in the middle of the pit wall, middle of the pit tips. And the third one that is not clear here is on the topography surface at the pit rim. When I click to go to the end of pit 4, you see that at the pit rim here, the pit wall is pushed back toward the north. So again, I can graphically investigate how this pushback strategy, as well as mining rate and movements of the walls, and especially the rate that the pit floor is deepened, is viable, is applicable. And if I notice any problem, I should go to the previous steps and revise it. And you see here that at the end of year 6, we have a very deep wall that must be pushed back again toward the west and northwest. And this year, together with the next, that is year 7, are very difficult in operations because of this very high wall that must be pushed back. This is one of the places that must be investigated more in tactical planning, and tactical planning can help us make sure that if transition from year 6 to year 7 is applicable or not. And this is the end of the life of mine. Here the pit is finalized. As you see, this This design, or I better say, this shell is not designed, and it needs geometrical designing, especially implementing the ramping system. In another stage, I can take these here, these 5 nominated pushbacks to a GMP general mining package such as SERPAC, and design the geometry, including working phase and especially the ramping system, and take those conceptual designs back to the Whittle and rerun this schedule to make our results from strategic planning more practical. How was that? Is it clear, or does it need more description?
No, I think that's like you've pretty much covered everything that I was asking.
All right. So let's end this session, and in next session we can discuss about tactical planning through 1 or 2 examples. All right.
Yep, sure.